I'm doing page 567, problem number 18, and the direction is use the results of exercises 9 through 14 to find a solution to the initial value problem. So the given problem is y double prime minus 8y prime plus 16y is equal to 0. And that is exactly the same thing as problem number 12 if you look in your book. And the initial values that are given are y of 0 is equal to 1 and y prime of 0 is equal to 1. So the result that we found from 12b is this equation here. And so we have y is equal to c1 e to the 4x plus c2x e to the 4x. All right, so then you want to first of all find, using the initial value of y of 0 is equal to 1, and I'm just going to be directly plugging into this equation y of 0, right? So you have y of 0 is equal to c, and then if you put in 0 for x, you get e to the 0. And this is just going to drop out because x is 0, so if you multiply this thing by 0, then it's just going to drop out as 0. And then that is equal to 1, right? So the 1 comes from here. So then solving for c1, that gives you c1 is equal to 1. For the second part, I'm just taking the derivative of y prime, or the y prime, which is a derivative of y. So I'm taking the derivative of this line here. So this would become 4c1 e to the 4x, and then I have to apply the product rule on this. So that will be c2 e to the 4x, and then plus 4c2x e to the 4x. Okay, now I'm going to be doing some substitution. So I'll be using the initial condition on this one. So it says that y prime of 0 is equal to 1. So I'm looking at y prime of 0 equals, so for all of my x's, I'm going to be putting in 0. And then for my c1, which I found in the first part here, that's going to be 1. So I have 4 times 1, and then it's going to be e raised to the 0 power plus, and then it's c2, and then I put in x is equal to 0 for this, so I get e to the 0. And since x is 0, this is also going to drop out, and then that is equal to 1, right, from this part right here. So then when I solve this, I get 4 for this portion because e to the 0 is 1. And then c2 times e to the 0 is just going to be c2, and that is equal to 1. So then I get c2 is equal to negative 3. So now putting all of this together, I'm going to put it back, the c1 and c2 back into this equation here. So my final answer on this comes out to be y is equal to 4, or e to the 4x minus 3x e to the 4x. Okay, so on your homework, problem 11 and 17 are similar to the two problems that I did for 12 and 18.